Connecting graphs to equations, Part 1. In this video, you'll learn how to describe the connections between an equation of the form ax plus by equals c, the features of its graph, and the rate of change in the situation. You'll also learn how to graph a linear equation in standard form. So let's start by looking at standard form. The standard form of a linear equation is ax plus by equals c, where a and b represent the coefficients of x and y, c represents the constant term, and x and y represent any point on the line of the graph. So let's look at an example in standard form. Suppose a person wishes to travel 12 miles a day by running and swimming. He runs at a speed of 4 meters per minute and swims at a speed of 2 meters per minute. Let's write an equation to represent this situation. So we'll take an equation in standard form, which is ax plus by equals c, and replace our coefficients and constant by what this story tells us. First, we need to determine our variables. We'll let x represent the minutes running, and y will represent the minutes swimming. Since we know that he runs at a speed of 4 meters per minute, we can replace a with 4, since x talks about our running time. We also know that he swims at a speed of 2 meters per minute, so we can replace b with 2. Finally, we know that he wants to travel 12 miles a day, so we'll replace c with 12, since that's what we want our equation to equal. Now we have an equation in standard form to represent this situation. We'll learn a couple other things, and then we'll come back to this. Now let's talk about intercepts. The x-intercept is the point where y equals 0 in the function. So the coordinates of the x-intercept will be the value of x that we have, and y will always be 0. The y-intercept is the point where x equals 0. So the coordinates of the y-intercept will always have x as 0, and then y will be where it crosses the y-axis. So now that we know what intercepts are, let's find how long the person in the last example must run if they do not want to swim. So we'll take the equation that we made of 4x plus 2y equals 12, where we said x would be the minutes running and y would be the minutes swimming. Since we know that the person does not want to swim, we'll replace y with 0, and now we can solve for x to find how long he has to run. We'll start by simplifying, so we have 4x is equal to 12. We can solve for x by dividing both sides by the coefficient of 4, which gives us x equals 3. So if the person does not want to swim, he'll have to run for 3 minutes. Now let's look at the slope of a line. The slope of a line represents the rate of change. This is how the y value changes compared to the x value. So now let's go back to our example and find the slope of that situation. We'll create a table of values for the equation we created from the running and swimming situation. Using a table is one way to find the slope. So we know that the equation we created was 4x plus 2y equals 12. We'll use this equation to fill in the blanks of the table where x is 0, 1, and 2. We can find the value of y by replacing x with 0 and then solving for y. Since 4 times 0 is 0, and adding 0 to 2y won't change the value, we can simplify this to 2y equals 12. And then we'll isolate y by dividing by its coefficient of 2 on both sides. So we get an answer of y equals 6. And we'll put this into our table. Now we'll find the value of y when x is 1. So we'll replace x with 1, and this gives us 4 plus 2y equals 12. Now we'll start solving for y by subtracting 4 on both sides. This gives us 2y equals 8. Now we'll divide both sides by the coefficient of y, which is 2. This gives us an answer of y equals 4. So we'll put this in our table. Now let's find the value of y when x equals 2. We'll replace x with 2. Multiplying gives us 8 plus 2y equals 12. We'll solve for y by subtracting 8 on both sides, giving us 2y equals 4. Now we'll divide by the coefficient of 2 on both sides. This gives us an answer of y equals 2. So we'll put this in our table, and now our table is completed. So let's talk about the slope. So the slope is the change in y over the change in x. So we need to see how our y values change compared to our x values. Our x values are increasing by 1 each step. Our y values are decreasing by 2 each step. So -2 will go on top to represent our change in y, and +1 will go on the bottom to represent our change in x. -2 over 1 can be simplified to -2, so our equation has a slope of -2. Now let's talk about slope-intercept form. The slope-intercept form of a line is y equals mx plus b, where x and y represent any point on the line of the graph, and m represents the slope of the equation, and the value of b represents the y-intercept. To convert standard form to slope-intercept form, we just need to solve for y. So let's convert the equation that we created for the athlete into slope-intercept form. Slope-intercept form is y equals mx plus b. So we can take our equation in standard form and isolate the variable y to put it in slope-intercept form. We'll start by subtracting the 4x on each side. This gives us 2y is equal to 12 minus 4x. Now we'll divide both sides by the coefficient of 2, which gives us y is equal to 6 minus 2x. So we have our equation solved for y, but in slope-intercept form, the x term should go first. So we'll just switch our order and put y equals -2x plus 6, so now everything matches up with slope-intercept form. We can see that in our equation, m is represented by -2, and since m tells us our slope, then the slope of our equation is -2. And this matches what we found a couple slides ago when we filled out our table, so our slope is definitely -2. And the value for b in our equation is +6. B represents our y-intercept, so in this equation, 6 would be the y-intercept. And we can confirm this because when we made our table, when x was 0, y was 6, so that is definitely the y-intercept. Let's look at this example. Andre bought a new bag of cat food. The next day, he opened it to feed his cat. The graph shows how many ounces were left in the bag on the days after he opened it. So our x-axis represents the days since he bought the bag, and the y-axis represents how many ounces of cat food are left in the bag. How many ounces of food were in the bag 12 days after Andre bought it? So we need to find the value of y when x was 12. So if we go to where our dot lies on the graph, we can see that there were 36 ounces left in the bag. How many days did it take the bag to contain 16 ounces of food? This time we need to find the x value when y is 16. So from the point on our line, we can see that it took 24 days for the bag to contain 16 ounces of food. How much did the bag weigh before it opened? So this will represent our y-intercept. This is when x is 0, since no days have passed since he bought it. And we can see that there were 56 ounces in the bag before he opened it. Let's recap everything that we've learned. Standard form of an equation is ax plus by equals c. And slope-intercept form of an equation is y equals mx plus b. The x-intercept of a line is the point where y equals 0. And the y-intercept of a line is the point where x equals 0. The slope of a line is the rate of change and how the y values change compared to the x values.